Okay, good everyone. Today we are going to have another topic today in practical physics. In practical physics, we are going to treat about the simple harmonic motion experiment. This is what we are going to do today. Well, welcome once again to kossydgreat channels. Today, in simple harmonic motion, I'm going to teach you how to, complete your table of values or fill up your table of values without any delay. We call it a shortcut. Just make use of your calculator by having your calculator ready with you. We want to talk about the shortcut. Now, how do I fill up this table of values if this thing is given to me or if I'm in exam hall? What I'm going to do is I will read the word instruction given to me very, very well, because if it is WAEC, they will give you instruction. There is no practical you are going to write as exam that you will not carry out an instruction. So in that particular practical, we know that in simple harmonic motion, T is equal to 2 pi square root of L over G. This is the relationship between the length of the thread and the period. Now the period of this oscillation is related with the length using this formula. Now where L means length of the thread. Now, and the G is acceleration due to gravity. And our G is giving us 9.8 meter per second square. This is the acceleration due to gravity, which is 9.8 meter per second square. Now in this case, if you come to this particular place, you can see that to perform this practical, there are two formulas you are going to know. Which this is the first formula, and the second formula is look at this formula. That period is equal to T over N. Period is equal to T over N. We have formula number 2. These are the two important formulas I need in every simple harmonic motion experiment of a pendulum ball. Now in this case, let us go to this place. When you look at our table, you see that the length is given in cm, not in meter. But we have our acceleration due to gravity as 9.8 meter per second square. Look at the times are in second, but the length is in cm. There is need of conversion. How can we convert? If our G is equal to 9.8 meter per second square, can we remember that if I have 1 meter, that 1 meter is equivalent to 100 centimeter. Now if you remember this, note this thing down. If you remember this, I can come here and say that I have 9.8 times 1 meter per second square. I am correct. 9.8 times 1 is 9.8. So if 9.8 times 1 is 9.8, any place I see 1 meter, look at 1 meter, I can represent that 1 meter with 100 centimeter. So in that case, our G is equal to 9.8. In this place I have 1 meter, I can call it 100 centimeter per second square. So finally, our G is equal to, this time this will give me 980 centimeter per second square. Now, because the practical requires or the length of the practical, the thread is measured in centimeter. That is the need of the conversion. So I will come to this particular formula and modify it. This becomes 980 centimeter per second square as our G. So in this case, we have gotten that acceleration due to gravity is 980 centimeter per second square, which we have substituted as our g in this case. Why? Because of what? The length is measured in centimeter. Now in this case, my practical now, the formula I need for this shortcut now, for this manipulation is what? This first one, and again, if our t is what? Small t over what? N. As we have as what? Formula 2. This small t is what? This small t, which is t average. We have known the what? The number of what? Oscillation as 20. They must give it to you. Then the period, which is our t, is gotten from where? This equation 1. When the length is what? Given. Look at the length. So when the length is what? 90, you put 90 there to get your period. Immediately we get our period, you put your period here with your number of oscillation to get your t average. You can now see, these are the two important word formulas. I can now say, for the length equal to what? 90 cm. Let us solve. Let us fill up the table of values. What am I going to say? Our t is equal to 2 pi square root of what? What is our L? 90 over what? 980. Now the problem of this thing is what? How do we press it? You get your calculator. First of all, press 90. Look at 90 divided by 980. We are going to have something like what? 2 pi square root of everything here is what? 0.0918. Now when you press it, this is what you are going to get. Now you can now see that we have gotten the whole of this thing as what? This. Now we have square root of it. We have square root of what? The answer we have. We are getting our period to be equal to what? 2 pi times 2 pi times what is the whole of this thing? We got it as what? 0.3030. Now the whole of square root of what? This thing gave us what? 0.3030. Now in this case, we need to use this thing to multiply 2 pi in order to get our period. If you are using your calculator, how do we do it? Just multiply, press times 2. Then if you want to get this shift, this pi, you press shift. When you press shift, you go and press exponent, ESP. This ESP, you are going to, once you press it, you are going to see pi. That is 2 pi. We have gotten this thing times what? 2 pi. So when you press equal to, we are going to get 1.90409 and so on. So approximately, I am going to get 1.9041. So you can now see that what? Our period is what? 1.9041. Now I've gotten this one. How can I get the other one? According to indices, t square, period square, which means this particular value times what? Or square 1.9041 square. When you square it, you get what? 3.6256. Then, after getting this one, how can I get this one? This is what T mean. And this one means what? This particular thing means T mean, T average. That is the small t. So how can I get small t? From equation 2. If our t is equal to small t over what? N. Make this one the subject of the formula over 1 cross multiply. This implies that what? Small t is equal to what? Period times what? N. So in that case, I can say that what? Small t is equal to, look at it, our period is what? 1.9041 multiply it your n, which is what? The number of oscillation. And what is the number of oscillation? Multiply by 20, which means 1.9041 times your number of oscillation is what? 20. We are going to get 38.082. But due to this what T mean is as a result of what? T1 and what? T2. And T1 and T2 are gotten from the stopwatch, which means if we are measuring it because of what? It is what? A value we can get from an instrument. Then what are we going to do? What is the standard value or the measurable accuracy of what? A stopwatch? 0.1 seconds. So in that case, if we are taking any value here from the T mean, remember T mean is gotten from what? T1 and T2. We are going to take that value as a result of what? The value of the what? The instrument, which is what? Stopwatch. So therefore, I can say that what? This is what? 38.1 seconds. Because of what? The standard value of what? The stopwatch is what? 0.1 seconds. So in this case, what can we do? I will come here and say this is what? 38.1 seconds. I am not going to take it what? Any further. Why? Because we are taking it to 1 decimal place. We are taking this into 1 decimal place because of the stopwatch is what? In 0.1 seconds. Now how can I get T1 and T2? After getting 38.1 seconds as the T mean, how can I get this? I will put plus or minus of what? 0.1. I can use 0.1 as the error. Now in this case now, why do I put 0.1? What I'm trying to do is what? What can I call my T1 and T2? That whenever I sum the two values, I am going to divide it by 2, I'm going to get this 38.1. I will now say, I will add 0.1 to the value, to this value, and I can subtract 0.1 from that value again. So in that case, I can say 38.1 plus 0.1 will give us what? I can come anywhere in this T1 and T2, either T1 and T2, and put what? 38.2. That is the value I got. Then this is for addition. Then if I say 38.1 minus 0.1, I am minusing it. I have added 0.1, now I am minusing 0.1. I am going to get 38.10. So if you look at these two values now, when you add these two values and divide it by 2, as we have here, T1 plus T2 divided by 2, you are going to get this thing back. So let's check. 38.2 plus 38.0 will give us what? 76.2. Now if I divide it by what? 2, I am going to get 38.1 back. You can see this is how we are going to fill up what? This table. This is when L is what? 90. Now, what about a case whereby our L, I am going to be a little bit fast here. When L is what? 80. What are we going to do? You now say T is equal to 2 pi square root of, what is our L? We have what? 80 over what? 980. Then when you press it, how do we press it? 80 divided by 980, you have your answer. Then square root of that particular answer, you have your answer. Multiply by 2 shift exponent to get pi. That is 2 pi. What we are going to get here is what? 1.7952. So which means we have 1.7952. When you square it, we are going to get 3.2227. Then coming to the other one, if I want to get this, what's our formula? Our T mean is equal to period times what? The number of oscillation from the formula 2. And our period here is what? 1.7952 times a number of oscillation is what? 20. In this case, what do we do? I can now say 1.7952 times 20. It will give us what? 35.9. Remember, we take this one, we take it in one decimal place. So what do we do here? This 35.9 plus 0.1 will give me what? 36.0. Then we now have 35.9, the same value again, minus 0.1 will give us what? 35.8. Now this is how we are going to what? Fill up what? The table of what value. You can complete other ones. Now if you look at this, you can see when the lengths are what? Changing, the period are also what? Changing. So that's the reason why we have that what? The period is what? Proportional to what? The length. So thank you for watching this wonderful shortcut in simple harmonic motion. We have so many practicals in simple harmonic motion we are going to what? Treat here. But this is under pendulum bob of what? Giving lengths. So thank you for watching this wonderful thing. Thank you and God bless you. Follow us at what? Kossydgreat. Thank you and God bless you.